Welcome dear students. In today's lecture I am going to explain about the ratio test of convergency. The infinite series summation n is equal to 1 to infinity an is there, and if the limit n tends to infinity an plus 1 over an is equal to L, suppose, and if this limit L is less than 1, then the series is convergent. More than 1, the series is divergent, and if it happens to be equal to 1, then the test fails. So in the root test, in the previous lecture, I have explained you about the root test. In the root test, we have to check for an power 1 by n as the limit. In the ratio test, we are going to check like this. Now let us solve a problem on this. So the problem is summation n is equal to 1 to infinity n factorial by 10 to the power of n. So what is an here? An is given by n factorial over 10 to the power of n. So our job is to find out an plus 1 because you are using now the ratio test, correct? So now an plus 1 is what? In the place of n, you just put n plus 1. That means n factorial must be replaced by n plus 1 factorial over 10 to the power of n plus 1. This is what should happen. So now it is n factorial by n. Now what we have to see, find out what is limit n tends to infinity an plus 1 over an. So what is this limit? N tends to infinity. What is an plus 1? Is n plus 1 factorial over 10 power n plus 1 over now an. An is what? N factorial over 10 to the power of n. This is an plus 1 and this is an. So now we can flip the fraction, right? So it is limit n tends to infinity n plus 1 factorial over 10 to the power of n plus 1 can be rewritten as 10 power n into 10. Now flip the fraction 10 power n over n factorial. Now this 10 power n gets cancelled. So now we can write n plus 1 factorial as limit n tends to infinity n plus 1 times of n factorial by 10 times of n factorial. Why I am writing n factorial? Now look at this result. N plus 1 factorial can always be written as n plus 1 times of n factorial. Let us now look at some examples for this. Suppose if it is 5 factorial. How can I write 5 as 5 into 4 into 3 into 2 into 1, correct? So can I rewrite this as 5 into 4 factorial? This 4 into 3 into 2 into 1 can be rewritten as 4 factorial, right? Similarly, 4 factorial can also be written as 4 into 3 factorial. In the same pattern, that means 4 into the same number into its previous number factorial, 3 factorial. So now it is n plus 1 factorial can be written as n plus 1 into its previous number is what? N factorial. So like this we can rewrite that n plus 1 factorial can be, so that I can cancel this one. Now as n is going to infinity, infinity plus 1 by 10, which is again infinity. Now infinity is greater than 1. Therefore, the series is divergent. The series is divergent because the limit is infinity and it is greater than 1. So the series is divergent. So let us look at one more problem. Now here, what is the nth term here? An is given by n plus 1 times of n plus 2 over n factorial. Now what is an plus 1 here? Just in the place of n, replace n plus 1. So that becomes n plus 1 becomes n plus 1 plus 1, correct? So it is n plus 2 and n plus 2 becomes n plus 1 plus 2, that is n plus 3. N factorial becomes n plus 1 the whole factorial. Now since we are doing the ratio test, we are now going to find out limit n tends to infinity, an plus 1 over an. So what is limit n tends to infinity? What is an plus 1? Let us write down that. That is n plus 2 times of n plus 3 over n plus 1 factorial divided by. Now this is your an plus 1, okay? And this is n plus 1 times of n plus 2 over n factorial. This is your an. Now when there is a fraction in the denominator, you have to flip it, right? So it is n plus 2 times of n plus 3 by, again I can write n plus 1 factorial as n plus 1 times of n factorial. Now flip the fraction, n factorial over n plus 1 times of n plus 2. So now this n factorial gets cancelled, and this n plus 2 gets cancelled. So what I am remained with, limit n tends to infinity. In the numerator I have got n plus 3, and in the denominator I have got n plus 1 the whole square. So even if you put now as limit n tends, whenever n is there, immediately you can take n common, so that it is 1 plus 3 by n. Now as n goes to infinity, this term goes to 0, correct? So that's why what you have to do always is taking n as common. And now here also, when you take n common, then it will be n into 1 plus 1 by n the whole square. That means n square into n plus 1 the whole square. Now 1n gets cancelled, right? Now as n is going to infinity, this is 1 and this term is 1. The numerator becomes 1 and the denominator also becomes n into 1 plus 1 by n, it is infinity. So what is this value? 1 over infinity. So limit n tends to infinity, it becomes 1 over infinity, and the value is 0, and 0 is less than 1. Therefore you can declare that the given series is convergent. I hope you could understand. So since the limit is less than 1, the series is convergent. Thank you.